And so we got some videos and we have some slides that'll describe kind of the general conditions that we see in Marina Del Rey on a regular basis. There's always anomalies, there's always surprises, but these are the basic weather patterns that we see throughout the year. And we're going to start with an explanation on the sea breeze and compare that to the land breeze, and then go through inversions, the summer monsoons, winter rains, and the Santa Ana winds in the winter. I can get rid of that and say hello to everybody. So at the end of Saturday's class, Carson had asked, why is the wind light in the morning and windier in the afternoon, if you remember. So I'm going to start this little video and it will tell you the answer to that question. And then we'll talk a little bit about our thermal sea breezes. Okay, so we'll get it started, and I get the right. Oh, here we go, and optimize. Go to full screen.
Okay, today we're going to describe the motion of sea breeze versus land breeze. We're going to start with the sea breeze. You can see in our diagram here, we've got a daytime scenario, and we're going to describe why the air in this particular location is moving in this particular direction. First, let's talk about some of the things we've already discussed, which is high pressure area versus a low pressure area. We know that the air wants to move from a high pressure to a low pressure. And so we can see this arrow down here. This is showing us the sea breeze here at the surface. The air is moving from the ocean out onto the land. Well, why does that happen? Well, let's take a look at the land. First off, in comparison to the water, the land is warm. Okay, so then that leaves us with this cool ocean water. So as the air drifts over the land, it's going to be heated because the land has been getting warmed up by the sun throughout the day. So as it's heated, it becomes less dense. As it becomes less dense, we know that this air is going to rise. And when it rises up into the atmosphere, we know that as it's allowed to expand, it's going to naturally cool, and it will drop in temperature. So it's got that drop in temperature, and then as it's being forced out over the ocean, since the ocean's a cooler area, it's going to cool even further. As it cools, it becomes more dense, and then that air is then going to subside. And so if you recall, we spoke last week about subside. It's just another word for sink. So this air is going to sink back down to this high pressure area out over the ocean. And so this is how a sea breeze is generated. Now let's compare a sea breeze to a land breeze. So notice what's changed is that now the sun is down, and so we're going to go ahead and compare the temperature of the land to the water. The land has now cooled in comparison to the water, which is now warm. Above the land, we've got a high pressure area versus a low pressure area out over the warm ocean. Once again, we know that air is going to flow from a high pressure area to a low pressure area. So as you can see, we're going to reverse our direction of airflow for land breeze as compared to the sea breeze. So the low pressure, as a result of this air being heated, it heats up, so that causes it to expand. It's less dense, rises up into the atmosphere, and then it's going to eventually cool as it rises. As it's being pushed over the cool land, it's going to cool even further, which means it's going to now become more dense, and then it is going to subside or sink back down to the surface. So this is what is happening for a land breeze. We've got the air moving from the land out onto the ocean. One last time, let's compare that to sea breeze, which is the opposite direction. During the daytime, we've got the wind blowing from the ocean out onto the land.
Okay, so, hang on a sec. All right, so that's a short and sweet discussion about our thermal breeze and how it develops. So a couple things that we know about that is that in the morning, the land hasn't had a chance to heat up yet. And so everything's pretty calm because, as we learned Saturday, we're in an area of descending winds in general, creating a high pressure system, keeping things nice and sunny and relatively warm. As the land heats up, then it starts rising, the air starts rising above it, and new air moves in to fill it. And of course, as the land gets hotter, it rises more quickly and more breeze comes in. And so that goes on. And so by the afternoon, by 5 o'clock, 6 o'clock, the wind could be blowing 13, 14, 15 knots, where it's going to start off the day at 11 o'clock at just a few knots, 3 or 4 maybe. If the land cools off enough at night, sometimes when we go and we set the boats up, we'll actually feel that breeze going offshore. But that's somewhat moderated somehow, and I can't explain why, in Marina del Rey. So then there's another thing that does happen as the sea breeze builds. So the land's getting warmer and warmer, and it's pulling in more and more air from the ocean. It tends to move towards the west. So we see the direction change, say from 235 to 240, sometimes even 245. And that's essentially because the same factors that cause the air to turn and become our prevailing breeze, that's called the Coriolis effect, that bends the wind, because now all of a sudden it's got enough mass. This is a local event that happens not very from the 405 to say 10 kilometers out. And so it's really a very local phenomenon. And so that's why as we see the breeze builds in Southern California, typically we'll favor the right side of a race course. So Laurent, you got anything on that?
Yeah, I can add a few things. I'm gonna share the screen with this and talk about it a little more. Let me show you that. Give me a second. Let me get it set up right here to share the screen. I need where's my app right here? Where is it? Sorry about that. Give me a second. There's an app that I need. Can't find it. Let me share that screen real quick, and then I'm going to come to you. Okay, so the things that I want to explain is basically there's a few more. The one component that the guy didn't explain very much about it is why the land is hotter than the water and why the land is cooler than the water. That's something that's important to understand why, because that's why the whole thing works. Is first of all, variation of temperature of lands are quicker and bigger than water. Water have a tendency to retain heat and retain cold. So knowing that, so one's going to move faster than the other. And so I can't find this app. Give me 1 second real quick, so I can explain it and make it a little bit better. Where's that app? Oh, there it is. Okay, cool. All right, let me share it now. Share screen. There, share. All right. So if I am right here. So as you say, right, let's say this is the water, right? And this is the land. So this is gonna, warm a lot quicker and get cold a lot quicker than this part here, which is a more tempered mass. Now, here's the thing. The wind is gonna go from here to here. Why? Because this is what he explained. This is warm, then it gets lighter, then it goes up, and then this one comes from here. At that time, it's gonna move this way, and this one's gonna aspirate that way. So that's the whole thing that he explained here. Why? Because that one is lighter, goes up, then becomes cold, comes down. As it moves towards the ocean, it moves this way because it needs to go somewhere, right? As this one goes up, this one is aspiring the wind from there. So that's what's happening right here. Now, when you know this, there's something that's pretty important to find out, is like when we navigate in Santa Monica, there's a few things that are also more important. It's like, let's say why it's very strong in Marina del Rey, and it's very strong in some, as Steve said, it's a very important factor in California. Why? Because if I just had a landmass is one thing. Now, if I had a lot of trees there, that's going to become even warmer. If I put things like the streets, the concretes, it's even going to become more warmer. So all this becomes so hot and so warm that it's the high pressure, the low, it becomes even more. At the low pressure, so it becomes even higher. So then it's warmer, and then automatically move a lot faster, because it gets warmer a lot faster, and the wind comes here. Knowing this is where it's important actually, and I'm going to show you a new one. It's right here. New one right here. Now, understanding that. Let's say I have some kind of a mountain going on this way, right? The sun is coming here, right? This part is going to become warmer quicker than that one. So automatically you're going to have a wind going on this way during the day. At night, it's going to go the other way. So knowing that again, it's also something that makes it important. Now, if I'm going to add another parameter to this, now, this is something that's actually pretty important. Now, let's say I have my water right here, and I have a cliff right here, and then I have my landmass right here. So of course, you're going to tell me the wind's going to come from here to here. But guess what? There's a big wall right here, a huge wall. So when the wind's going to come right here and hit that part right here, it's going to create some kind of turbulence before that one's going to be smooth. But right in here, you're going to have big turbulences. So if you're navigating during the day and you're getting too close to that cliff, your wind might very surprise you. So you don't want to get too close to it, which is why, and I'm going to bring you to that one now, when you channel, and you're racing you're racing in the Santa Monica, right, at night, you have that main channel right here, right? And this is where you start, and you're going to go there to the outside channel. So now you have all those big buildings right here, right? The wind is coming from there. So if you get too close to here, it's the same thing, because why? It's the exact same thing that what I told you before, except it's on the other side, but it's the same thing. If the wind is coming from here and you have a building right here, before it comes down there, guess what's happening here? You have turbulence, dead wind, you have a lot of things that is not going to happen so nice. So what you want to do when you navigate the channel, and it starts, especially when it starts to get a little bit later and the wind shifting and it's not as strong, and you're navigating that channel, if you get too close here, you're gonna be a lot slower than if you get right here where the wind gets a lot stronger. If you get too close here, same thing, you're gonna have the same issue again, because you're getting too close to those high, you know, especially next to the Fisherman's Wharf, not Fisherman's Wharf, next to the market, like, you know, that big place, which is pretty high of a dock. Again, you're going to have some bad winds right here. So you want to stay where the wind is the strongest, which is right in the center of that channel. And that's actually because when you understand the wind goes somewhere, it has to go and it has to flow. If you have something that's going to block the flow, it's going to get a real trouble for you, especially when you're racing and you want that big wind and that main wind going on. You know, it's also, you know, observing all this is important because it works not just for sailing. Let's say you're paragliding, right? And you heard about that, which is like a little parachute, right? And you're like this, right? You're on your chute. What you want to stay in the air as much as you can. So what you're going to identify are going to be all those things on the land, like tree, forest, all that stuff. If you're going to fly over a forest, it's going to get hotter here. So the wind's going to get up and it's going to get you higher. If you're going to go next to it, then you're going to go down. This is how those guys stay hours and hours and hours and hours in the air because they identify where the wind goes up and where the wind goes down. All right, Steve. This is
Okay, cool. All right, thanks. So I think Oliver says now he wants to go paragliding. All right, so great, thanks. So now we're going to, we'll go to another video, and this talks about inversions. And inversions typically can be associated with smoggy days and light sailing conditions. Here we go. Which one is it? There we go. Share, maximize.
This is Dwayne Friend with University of Illinois Extension. Normally, air temperatures get cooler the higher you go. However, there are times when air at higher elevations is actually warmer than the air below it. This creates what is called a temperature inversion. The atmosphere is mostly heated from the Earth's surface. Sunlight, in the form of short wavelengths of energy, travels through the atmosphere and is absorbed by the Earth's surface. The energy is then emitted back into the atmosphere, but at longer wavelengths of energy. The atmosphere is heated from these longer wavelengths. The farther from the heat source, which is the Earth's surface, the cooler it gets. On calm and clear nights, the Earth's surface can cool very quickly as it loses heat or radiation, cooling the air right above it. At higher elevations, the air doesn't cool as quickly, so this air becomes warmer than the air below it. A temperature inversion occurs when this happens and is called a radiation inversion. Fog may also form if the cooled air is moist. On coasts, a cool ocean breeze can bring cool air onto land. This creates an advection inversion and is very common along much of the California coast. Because the air doesn't mix with other air, pollutants can build up when an advection inversion is present. Sometimes air high in the atmosphere starts to sink. As it sinks, it begins to warm due to the air being squeezed or compressed from the higher air pressure at lower elevations. The sinking air can warm to the point it is warmer than the air below it, even hundreds or thousands of feet above the Earth's surface. Called an upper air inversion, it acts as a barrier to keep thunderstorms from forming. Most inversions last only a few hours, although some may last for days. When this happens, it can cause very poor air quality as pollutants can build up.
Okay, so that's a relatively simplified explanation about you know, it can be a real problem for certain areas. In the winter, we often get these cool nights, and the ocean's already cold. And so between the land cooling off at night and then the ocean being cold, we've got a nice cold layer of air on the ground. And we know that we have this descending air because we're in the feral zone. So that typically we have that descending air, and then we have prevailing winds, and those guys can just migrate their way up and create a cap. And those are, you know, a good reason for the smoggy days. And, you know, we'll see air moving at about the top of the coastal mountains, and it's trapping the pollutants and reducing the air mixture down below. So that's bad for pollution, but it's also bad for sailing because you don't have that mix. Your air, that when the land does start warming up, it takes longer for it to build up enough energy to break through that barrier and then start your sea breeze. So those are days that we start seeing in the fall, where we might get some breeze from 2 o'clock to 4 o'clock, and then it kind of disappears. And if you're looking towards the mountains, they're getting a little cloudy. Unfortunately, Carson's not here because this is a real phenomenon in Denver where he lives. And so there are nights where you get a high pressure system and it gets super cold on the ground. And the wind that flows over the Rocky Mountains is warmer, and it will trap it there for days. And I used to live in the mountains above Denver, and there were times when we would drive in and be in nice sunny skies and just look at the smog. It was a lot smoggier back in the 80s than it is now, and drive right into it. It was really kind of a disgusting thing. But so that's kind of a scenario that builds into the fall and early winter, when we have those lighter afternoons and sometimes some days that the wind never really builds up to a real fun sailing speed. So now I'm going to pull up some slides, and we'll go through those. Where is it? Okay, right here. And so we'll maximize that, get rid of the side. All right, so this is just a depiction of our typical sea breeze, but you'll notice also that warm air moving back towards the sea creates its own inversion layer there, which actually is good for us as sailors because it keeps that rotation moving. And it's moving offshore, so that inland the warm air just keeps rising and helps clear out the basin. All right, here's a demonstration of how it works in a mountainous zone where the wind gets compressed, warmed because it's getting compressed to rise over the mountains. You have cold air down below, and you can get that layer of inversion down below the mountains. So same thing here. We talk about this descending breeze that happens typically in our area year round without other major effects from the jet stream. And we can just have times when that air is coming down, compressing, warming up, and just making it nice and stagnant over LA. Okay, so as we get into the summer months, every now and then we get those days that are hot and muggy and some clouds roll in, and that is known as our monsoon season. So we have, basically we get a high pressure system that builds to the east of us, If you remember, the air closer to the equator is kind of paralleling, going opposite and paralleling the equator, and it starts trying to bend up. And when it hits this and brings moisture with it, hits that rotation around the high pressure system, which is clockwise, and it just funnels the moisture right up the coast. Usually this happens with the high pressure a little further to the east, and it winds up funneling that moisture up through Arizona, New Mexico, southern Nevada, southern Colorado, and we usually only see the tip of it. But it does create some interesting weather in LA. So here's a picture of what we call a straight line squall. And so this is where we're bringing warm, cold air hits warm air with enough moisture, and it creates some pretty interesting stuff. Now these, so the colder air comes in behind, hits the warmer air. The warm air starts rising, and then that compresses the cold air, which generates a lot of velocity right at that front edge. And these pop up a couple times a year. They're pretty rare. They're pretty easy to see. But in other areas where you're sailing, where there's more moisture in the air, less of that descending air to stop the accumulation of the clouds, then you can get some pretty severe thunderstorms. So we do see them every now and then. You can kind of look across the bay and you'll watch them come straight at you. A thin line of clouds here in Southern California, and they pass and they're gone in 10 minutes. Probably usually 5 or 6 minutes of pretty intense breeze, and then it calms right down. You might get a little bit of moisture on the back end of it. Okay, so now it's winter time. And in the winter time, the jet stream isn't as stable as it is during the summer. So we get bigger temperature differences between the polar zone and the Faro zone, and the jet stream will dip down. And if it dips down to the west of us, then that's what allows the low pressure systems to come through with the rainstorms that we get in the winter. And so as you see this, the low pressures stay to the cold side of the jet stream, and high pressures stay to the warm side of the jet stream. So as this entire picture moves towards the east, the low pressure goes with it, causes blizzards, across the middle of America. The jet stream gets out here, and then all of a sudden there's a high pressure system right behind it, and that's what brings us the Santa Ana winds. So the rotation changes to clockwise. These high pressure systems tend to stall in the Great Basin and build, and that circulation rotates clockwise and then comes blasting through the mountain passes to the low pressure off of LA. And that's how we get our Santa Anas and our fire season. So those are the slides. And so Laurent, do you have
yeah, I mean, I can, it says to talk about some other weather hazards and stuff. I mean, if you would be on the East Coast, you would hear about hurricanes, which is pretty.
Laurent, can I interrupt, and we'll go, let me answer a couple of questions that we
Sure.
got in the chat. So Henry's asking, what is a monsoon? And so a monsoon is, as I described, we have a band of wind south of us that's traveling the wrong direction as far as we're concerned. So it's traveling parallel to the equator, and it starts bending up with the Coriolis effect. But it tends to stay down there. It tends not to mix into our feral zone. But because typically everything moves from west to east, and this is moving from east to west along the equator. But when we get the correct rotation, which would be a high pressure system, and that's rotating it up, or a cutoff low. So to the west, it would be a cutoff low with the counterclockwise flow. It would suck it up, and a high pressure to the east, and that pulls that warm air with moisture up, contrary to the normal flows. So that's why the clouds in the monsoon come in, and so it brings up warm, moist air. And when it gets in between the two, the cutoff low and the high, it speeds up. When it gets out, say, over Arizona in the deserts, and they get their flash floods, it's because that hot air is, the ground's getting super hot, and it starts rushing up into the clouds that are being pulled up, and that creates
So it's like a lot. It's like a lot of
thunderstorm.
rain. So it's like a lot of rain. So
I'm
it's like a
sorry?
lot- So it's like a lot of rain.
It can be. It's not so much here because
Yeah.
the phenomenon tends to stay a little further east of us in the deserts, but we do see it. We do see it on the coast. We do. We had a few days last summer where we pulled everyone to the dock when we heard the thunder and saw the lightning.
I remember
That was so much
Yeah,
fun.
and
Yeah, it
and
was so
so
much fun. And then it cleared up.
right, and so Wikipedia will call a monsoon a contrary flow of warm, moist air. So it's contrary because it's going the direction we're not
Yeah.
expecting it to go.
But aren't there like really big ones in like Asia?
Say that again?
Aren't there like really, really big ones? Some things in like, not here, but like in Asia.
Yeah, so
Okay,
there's other parts of the globe where a monsoon is much scarier than it is here. No question about that. And don't ask me where. But
So I'm
Long
wondering, I was
Beach,
like,
when we do get the cutoff low and the monsoonal moisture, Long Beach is kind of for some reason, it tends to get hit harder than other parts of Southern California. So you'll hear about water spouts. They're always off of Long Beach. They're always in the monsoonal area. And, in Marina del Rey, we might not have gotten a bit of wind or even thunderstorms. So it's pretty localized. And again, we're generally on the edge of it.
that answers my question.
So, and then Oliver had a question, a very big storm, is that a fire? So no, this isn't a fire. That's just some, I have no idea what's going on in the background there.
It's weird.
But you
It
can
looks exactly like a fire.
Right. But so maybe that's a sunset. That's probably more likely what it is. But what you're showing there, what you're seeing is between us and the back of the cloud, there's a very straight line of clouds. And just behind that straight line of cloud, there will be some really big breeze, and that's typical of a squall. And so when we're out sailing, like if we take a trip to Catalina and we're coming back and we see a straight line like that, then we know that we can prepare for a pretty intense burst of wind that doesn't last very long, moves on by us. It's just a little bit of surprise. Okay, I'm sorry, Laurent, go ahead.
No, please continue. Continue.
Oh, I think I'm done. You were gonna talk
Okay.
about hurricanes.
So yeah, the bigger that wind's going to be, the bigger the pressure is going to be, the bigger the winds are going to be. Then you get to the highest point, which is the hurricanes for the Atlantic, the cyclone for the Pacific. And so it's pretty much the same thing. They just have different names depending on where they are. You know, best way, you don't want to be in it. That's the main thing. Definitely don't want to be in it. You're going to get some very, very, very high wind, very big rain, very big precipitation. It's not fun. It's very dangerous. So you want to be on your radio when you're navigating. You want to listen to the weather. You want to know, and usually you'll know when it's coming. And I'm going to share a little something that it happened to me when I was sailing in the Caribbean. It was back in the early 90s. Let me share the screen again. It was back in the early 90s in the Caribbean, in the Grenadines Islands. So what happened was pretty interesting. Let me share that. All right. Let me bring that here. All right. So I was in the Tobago Keys. The Tobago Keys, this is it. This is where we were. See, I don't know if you see it nice enough. It's a gorgeous place. You see, only small boats can get there. This is a place where you can see, you know, you can see the shadow under the boat. It's very nice. It's a gorgeous place to sail. You know, things like that. You have island like this, like just a piece of sand with a couple trees. So it's really fun, really nice. So we arrive at this paradise there. We spend the night. We wake up the morning, gorgeous day, and then suddenly we hear on the radio, Andrew is coming. It's a big hurricane, Hurricane Andrew. In a matter of, and I'm not kidding, in a matter of 10 minutes, 15 minutes that we heard the warning that it's coming towards us, it was pretty much 10 in the morning. It came from full light to almost night. And the weather stopped being pretty bad. So, and we're just on the edge. We're like not in the hurricane. So what we had to do a couple things. We had to get out of there. That's the number one. You can't stay in there because there's nowhere to protect yourself in here. So what you're gonna do, we took the boat and we went to an island called Union Island, which is the closest island that had what we call a hurricane hole, which is pretty much where you can go, and that's the island we were going to, Union Island. So it's maybe like a couple hours away, and we sailed over there to put ourselves right in here. You know why? Because there's mountains right here, and it's a U shape and mountains all around. And you remember what I show you with the wind, and you have obstacle, and it's protecting you with the wind. So you want to put the boat in there so you have less wind because it's completely surrounded by mountains. If you want to look at a picture actually of how it looks like, see you have mountains all around here and all around here. So you come here and you put your boat here. Then what you do in there, and that's the way it gets very interesting. You have to prepare the boat for it. And what we had to do, we had to put an anchor in the front, an anchor in the back. Let me stop the sharing right now. So you put an anchor in the front, an anchor in the back. And so the boat doesn't move too much. It doesn't go anywhere. It just stays in place. And with those two anchors, now you know there's going to be big waves. So what's going to happen with the big waves, you want the boat, since it has two anchors, you want the wave to go over the boat and not sink the boat. So you're going to make sure that everything on that boat, everywhere the water can come in, you have to make the boat completely safe. So what you have to do, you have to close every single hatches, every single doors, everything. So the water just goes over it and goes in the back. And then you prepare the boat like this. And at that point, you leave your boat and you go on land and you hide somewhere where it's safe to hide on land. You don't want to stay on the boat in any case. So that's what we did. We got pretty lucky because we just got the edge of the actual Andrew, which was already pretty nasty. I can tell you that we had waves, from like just going from Tobago Keys to Union, and that took us like 2 hours, and we had waves that were like 5-6 meters waves at least, and and we're not in the storm. We're on the edge of the storm. And so with all these waves, everybody got sick, there's no question. Everybody who tells you he's never been sick on a boat is a freaking liar. That's not true. So, sometimes you're going to get sick. Everybody got sick. Everybody got bad. And then we prepared a boat, we went on land, and we waited for it to pass. That was quite a scary moment. That was quite an insane moment. You know, it go from like these paradise pictures that I showed you to night and hail. It was hailing at the same time, by the way, in a matter of minutes. It's crazy. All right, Steve?
So that's great. So I'll share a little story about sailing in the Caribbean. It was in the Virgin Islands, and we were sailing across the bottom of St. John's Island, and we were heading to Coral Bay, which is the what they call a hurricane hideout, right?
Yeah.
A hurricane hole. And so we left, and we were just drifting. We had this big old 42-foot kind of really heavy boat that was great in a breeze, but it kind of was stinky in light air. And so it's hot, it's muggy, and we look to the west, and coming at us is a squall. It looked a lot more impressive than the one in my background. Really, really tall, straight clouds, and we could see the wind, and we could see the line. So the line of the clouds with the heavy rain right behind it made it really clear that this thing was bearing down on us, and we better pay attention. And so we went from virtually no wind, we're ready. You know, we knew it was coming, and so, you know, we put up all the sail we could, and we were going to go screaming down the coast. We weren't afraid of the wind whatsoever. And, you know, these things are tricky and they're fluky. And so by the time it got to us, it had kind of petered out. So all we got was wet. And so we wound up motoring into Coral Bay because we got no breeze that whole day. So, you know, these squalls can develop and then just dissipate because they're really localized, and they're acting on just that, those temperatures and those forces that are right there with you. And so as we pulled into Coral Bay with this famous hurricane hideout, this refuge, you come in the main channel and there's boats moored, and then everywhere you look, there's a mast just sticking out of the water. And so it's like, what the heck, you know? And so we went on to shore and we got some dinner, and we were talking to some of the locals, and that was everybody. Hurricane Hugo approached the Caribbean and took a really bad turn and turned and went straight north. So it's a southern exposure into the harbor, and it went straight north and just ripped the harbor and tore virtually every boat off its mooring, put them on the beach, sank them, all sorts of stuff. And this was 3 years afterwards, and there were still boats just sitting in the ground with just a mast sticking up. It was really something. And so the weather can be quite powerful. You know, we're lucky in California that we don't get a lot of extremes. I mean, certainly our fire season is extreme. But in general, compared to hailstorms, tornadoes, all these other things, you know, we've got great sailing conditions, nice warm temperatures, and it's sunny most of the time. So, and Henry asks, hope they had insurance. Well, yeah, you sure do. You sure do hope. You know, there's a lot of expatriates that hang out and cruise in the Caribbean on minimal dollars, and you really wonder, have they paid their insurance? Because I'm kind of guessing that the boats that were left on the sand and with the mast sticking out of the water in the harbor probably didn't have insurance.
Yeah.
So, any other questions?
I think someone asked how big the boat I had. It was about a 42 feet. It was a Centurion, Vauquier Centurions. It is a great boat, actually, gorgeous boat with a teak deck, and it was gorgeous, nice, fast. beautiful boat. But yeah, it was about 42 feet.
Okay, so Oliver, can you pull up a boat that sank and use it again? You wanna take that one, Laurent?
Oh, I'll let you take that one. That's an interesting question.
Okay, so you can. So the way they do it is they actually take bags and they open up the cabin and they swim in with bags and they float the boat up from the inside, and then they tow it in. If it's got a hull breach, of course, they got to tow it relatively quickly or try to get in there and try to mitigate how fast the water goes in to try and because it won't tow very well. But typically saltwater has its way. Once a boat's been completely submerged, you'd be talking a project that generally would cost more to do and take way more time than cashing in your insurance and buying a new boat.
Yeah, I think it's technically possible, but I don't think it's worth it. That's the key.
could you put a lot of helium in it? I guess if it had a big enough hole in the hull, you'd fill your bags with helium instead of just air to float it up. Then it really wouldn't matter how quickly it was sinking, right? You just have a lot less dense of a material, and then of course you could put nitrogen in there too. That's a little flammable, so that'd be a little risky. So
yeah, usually they do that stuff more for like, investigations and and historical wrecks and all that stuff. But for a Pleasance boat, for someone who wants to have and take his boat back, it's just too much work and not worth it.
Yeah, and another reason they'll do it, like for instance, if a boat sinks in its dock, well, it's got a motor that's got oil in it, and it's got fuel tanks with diesel or gasoline, and it's really an environmental hazard. And so they'll put flotation stuff and get it up and try to get it out before big spills. But so that's typically what we see in the marina would be derelict boats that aren't maintained properly and then actually do sink. And then you get them up there and get them out of the harbor so they don't do environmental damage. Okay, you guys are all full of questions. You're all wound up tonight. Any others? All right. Okay, so that's it. We're gonna try. You got any ideas of what you'd like to hear on Saturday? Since you guys are such great participants, what do you think, Henry, Oliver?
Wait, I have a question. What's the maelstrom?
What's a maelstrom? Maelstrom?
Yeah.
Isn't that just kind of chaos? I'm not positive, but I think it's just pretty much chaos.
I feel like I heard of it before being something.
Okay. I liked it better without that.
Okay, so we'll come up with some sort of fun topic for Saturday. Hopefully we'll see you then. This was a fun class, and have a good evening and the rest of the week. Thanks, Laurent.
Thanks, everybody. Thanks, Steve.
Bye.
Bye. Thank you.
Bye-bye.